Hello and welcome to the Daytona State College Advanced Cyberforensic Education lesson on the Windows 10 Registry. My name is Dan Purcell and I'll be your instructor for this lesson. I am a full-time law enforcement officer with the Seminole County Sheriff's Office in Orlando, Florida. I've been employed with the Sheriff's Office since 1995. My background in digital forensics began in 2000. When I took the International Association of Computer Investigative Specialists, or IASIS, basic computer forensics education course, and later obtained the CFCE certification, which is the Certified Forensic Computer Examiner certification. In addition to that, I'm also a graduate of the University of Central Florida Masters of Science in Digital Forensics, which I obtained in 2008. My background at the Sheriff's Office is I started the Digital Forensics, Computer Forensics program in 2000 and led that initiative for many years, including doing practical work in digital forensics for well over a decade and supervising that function until recently in 2014. I transferred from the investigative division that houses the digital forensics program back to the patrol division. My current rank is I am a captain with the Sheriff's Office and I currently oversee our patrol function. I'm also a graduate of the FBI National Academy. I attended the National Academy in 2013. So the purpose of this lesson is going to be focused on basic registry terminology and the structure. We'll also talk about the physical versus the logical registry and what that means. We'll talk about date and time formats found inside the registry, and then we'll spend a majority of our time looking at Windows 10 registry artifacts. So this lesson is going to be really at the cutting edge at the time of production here in December of 2014, as Windows 10 has not even been released yet, but working with one of the enterprise versions in the well beyond beta, but a release candidate for Windows 10. And then we'll talk about physical registry hive basics at the very end of the lesson, and then discuss the practical exercise that may be applicable to the class that you are currently enrolled in. The registry is essentially a large database that stores information about the local operating system. It also stores information about specific users as well. And some of the items that you'll be more akin to find inside the registry as it pertains to evidentiary items for your case or whatever your purpose is of conducting an examination would be items like programs and application settings, user settings and activity, logins and passwords, historical information about files and applications or perhaps services and processes that run on the machine. In addition, you'll also find hardware settings and of course information about services and processes that run on the local machine. The registry can be very daunting when you first look at it because of the sheer volume of information that's stored inside the registry. And although they may be stored, the items may be stored in a single Hive file, there are thousands and thousands of items, but realistically we're going to focus on the 10% of items that are really relevant to a forensic examination, including any type of e-discovery or cyber forensic investigation as well. So we'll start with the basics here. The registry is made up of core binary files called hives. And these logical files exist in strategic locations throughout the operating system. And the screen in front of you shows you where these items are typically stored. On Windows NT through Windows 10, you will find these files that are noted below, with the exception of the BCD file. The BCD file, which stands for Boot Configuration Data, it's a registry file that appears within the registry regedit program when you bring it up in Windows. We'll talk more about that, but it does appear there. This began in Windows Vista and continues into Windows 10. In addition, the other core files that you see here are System, Software, Security, and SAM, and they are all located in typically the Windows, the WinDIR System32 config directory. And then you also have the ntuser.dat files, which exist in the user profile folder and the root of that folder. So for example, in Windows 2000 and XP, we have the Documents and Settings folder, followed by a subfolder, which is the username, and then followed by the ntuser.dat file, which is stored inside of that username folder. However, in Windows Vista all the way up into Windows 10, you have a folder on the root of the volume called Users. And inside of the Users directory is the folder name for the username, followed by ntuser.dat. As evidenced by what you just saw on the previous slide, you'll see that not much has changed in terms of the basic Hive files that make up the registry. And not much has changed, as you can see, from Windows Vista, Windows 7, Windows 8, and all the way into Windows 10. The forensic applications that support viewing the registry data, such as Access Data's Registry Viewer and Encase, for example, they still support the registry data, as the format in general and file structure has not changed. The files that we're going to focus on in this lesson are pretty much isolated to System, Software, Security, and SAM, and of course they are located in the Windows System 32 config directory in Windows 10. The ntuser.dat file, once again, is located in the username directory, which stems from the users folder off the root of the volume, the Windows volume. In Windows Vista, Microsoft introduced a new registry file called BCD. It stands for Boot Configuration Data, and this file was intended to replace the boot.ini file that existed on the root of the volume in Windows XP. The boot.ini file does not support new architectures such as the Extensible Firmware Interface, the EFI firmware, and therefore it replaced it with the BCD registry file. The BCD is compatible with EFI firmware and standard PC and AT architecture, and it holds information about the operating system that can be loaded on the PC just like boot.ini. So when Windows starts, the core binary files of the registry hives themselves, they become active and they are loaded based on the applications within the operating system that allow those files to be edited. Now, it's important to distinguish between the active or the live registry versus the static registry itself. The active live registry is typically viewed in Windows with regedit or a similar program, but it's important to note that this is a limited view of the actual content of the registry in some cases, while in others it may reveal live content. For example, when we look at the SAM file, the SAM Hive, which is the Security Account Manager, this file can only be viewed from a very basic level, in fact only down to the second level of the SubKey, which is one of the folders that you will find inside of the registry Hive itself. Now, this can be changed based on permissions and viewing capabilities within that registry editor. However, most of the content cannot be viewed because Windows wants to protect the content. On the other hand, the static registry files, when they're viewed offline, Encase, Access Data's Registry Viewer, and other programs such as MyTech, they can all view these files in a static environment, thus providing you with the actual content and full file structure of the registry itself. It is important to note that in the live registry, there are hardware settings, for example, like the hardware key that is loaded into the live registry when Windows is running, and this is not viewable once the registry goes offline, meaning Windows is no longer actively running. Because the hardware configuration on a local machine changes so often based on items that are plugged into the motherboard or USB ports, SATA ports, etc., this particular registry key called hardware changes dynamically, and therefore it is not saved in an offline environment. So this type of information you would want to get from the live registry if it's relevant to your investigation. So when we refer to the logical registry, we're talking about viewing it through a forensic or non-forensic application that's capable of reading the Hive files, the keys, the subkeys, the values, and so on, and the parent-child relationship that exists between those items within the registry. On the other hand, we look at the physical registry, and it's the binary content of the logical Hive files themselves. So in order to understand the physical structure, you have to understand the signatures of the keys along with the values that exist within the physical structure of the Hive file itself. This is one of the topics that we'll cover at the end of this lesson so that you have a better understanding of the physical content inside of the Hive files and how to recover that data if you find something that's relevant to your investigation through a keyword hit or any type of manual analysis that you may uncover through your investigation. The registry has a hierarchical database structure, and as such you want to be familiar with some of the terms. Inside the live registry you see that we have a subtree, which in this case here in this screen is pointing to the HKey local machine. Underneath that you have keys, and these keys that exist under HKey local machine are hardware, SAM, security, software, and system. Beneath the system hive, in this particular case here, or the system key, you'll see that you have subkeys. And pretty much from this point downward through the structure, you will see a series of what appears as folders, which are actually subkeys. Now, in the right pane of the registry editor, you'll see that you have three columns. You have a name column, a type column, and a data column. These are the value data, the value type, and value data fields. So value name, value type, and value data fields. In the next slide, we look at the same type of view of the registry data as loaded in Access Data's Registry Viewer. To the left, you see the subkeys, such as typed URLs or URL search hooks or zoom. And in the right pane, you see the name, the type, and the data. So it has a very familiar look to you in terms of comparing this to the regedit application in Windows. On the very bottom of the pane, you also see in the lower right the hexadecimal view of the value and the value data itself. And then in the lower left-hand pane of Access Data's Registry Viewer, you see the key properties. And this is where you'll see the information that's displayed about the last modified time of the subkey itself. And you'll also see the information related to the value itself if Access Data's Registry Viewer is capable of interpreting that information. And so I'll show you examples of that in the next screen. Okay, so we're now looking at Access Data's Registry Viewer, and I've loaded the SAM hive, which is stored in the Windows System 32 config directory, and I've opened that hive file from my local machine into the program. As I navigate down through the tree structure in the left pane, you can see that the subkeys are apparent to you in the left pane. As I come down into the user subkey, I see a series of folders here that we'll discuss in more detail later on. And you'll see that when I click on any of these items over here, that the content is then displayed over in the right pane, and of course in the key properties pane and the lower left-hand corner, which is your key properties. For this particular subkey here in the SAM file, we're looking at the usernames and of course their SID and some of the items that are applicable to the usernames on the local machine. What's important about this information here is that Access Data's Registry Viewer allows you to look at the F and V values that are being interpreted automatically and then displayed for you in the lower left-hand pane or key properties. So for this particular example here, you can see that the local administrator account for this particular subkey is being displayed. It's the administrator account that's built into the machine. You see the number of times that the local administrator is logged in, including the last logon time, the last password change, and other relevant information for this particular user account. Next, we're looking at Encase version 7 to give you a feel for how this data appears inside this application. So I'm navigating down to the C volume, Windows, System 32, and then down to the config directory. And then inside of the config directory, I find the SAM hive. Inside of Encase, you can either run the evidence processor or the case processor to have Encase automatically mount this registry hive and process it, or you can also do that through Enscript technology. Likewise, to simply view the content of the SAM hive, you right-click over the file and go to View File Structure. When I go to View File Structure, Encase will then go in and look at this data and mount the SAM hive. When I mount the SAM hive or any registry hive inside of Encase, Encase prompts me and asks me if I want to calculate the unallocated space within the registry hive file itself, and also to find deleted content. When a registry value or a registry subkey or key value is deleted inside of a registry hive, you will find in the registry hive itself that values are changed to reflect almost like a file system that the item has been marked for deletion, and the content itself still stays inside of the hive file itself. So when I select either of these two options, mainly find deleted content, Encase will go and recover that information so that I can view the deleted content within the registry hive itself. So once I select OK to that prompt, I'm then presented with a hyperlink to the SAM hive, and when I click on that SAM hive, I am then taken under the Evidence tab from Viewing Evidence, Viewing Entry, and SAM to now viewing the content of the SAM hive. So now when I navigate down to the same area inside of Encase, I can now look at the content of the value itself. And so in this case here, I'm looking at the content of the V value name, and in the bottom pane of Encase, I'm now looking at the content of that value. And you can see here that this is the V value and the V value data for the administrator account. So again, inside of Encase, just a slightly different view. In the left pane of Encase, you're looking at the keys and subkeys. In the right pane, you're looking at the value name, and the value type is in another column. And then in the bottom pane, you are looking at the value data. The registry contains, in addition to the value name and value data, it also contains the value type. And there are different value types that you will find inside of the registry itself, and they are displayed for you on the screen. Some of those values that you'll find that are very common is reg none, which is no defined value type. It's probably just plain text data. Sometimes you'll also find that in reg sz, which is a null terminated string that's typically ANSI or Unicode data, typically Unicode in the current versions of Windows, including Windows 10. Others include a D word, which is a 32-bit number or a 4-byte value. You'll also find that you have 64-bit values in there, which is a Q word. Inside of Access Data's Registry Viewer, you'll see that these value types are displayed for you inside of the program itself. And so here on the screen, you'll see that the type is being displayed as a D word for the Know of Old Works areas. And the data, of course, is also displayed for you as well. And that is a 32-bit value. Beneath that, you also see a binary value. File time format is a file type or a file time format that you want to be familiar with. It's used very heavily inside the Windows operating system in both NTFS and related file systems, but also in the registry. The registry itself utilizes the file time format for the modification dates for each of the subkeys and keys throughout the registry hives themselves, but you'll also find the file time format is used for any type of values related to programs or user settings or even the date and time that a user may have accessed a particular application or a particular file. It's important to note too that the file time format is actually recorded in GMT or UTC, and so you have to be able to translate the regional settings on the local machine in order to get the correct offset from GMT and the correct date and time to be displayed. So the file time format, it's an 8-byte value or a 64-bit value, and it always ends in 01. I can say in my almost 14 years of doing digital forensics, I've never seen a file time value that did not end in 01, meaning left to right when you look at the data itself, and that's also evidenced down here in the bottom screenshot that you see for these file time values, which are separated by the red markers. And adjacent to each of those red markers that you see on the screen, you see a 01 value. So in Little Endian, actually the value begins with 01, but when we look at it left to right, just to qualify that statement, it ends in 01 when you look at it left to right. So what you see on the screen here is file time values that are of a file called Yahoo Messenger.lnk and the MFT entry inside of the master file table. And you'll see that the dates and times are being displayed for you in raw hex as taken from the MFT, and then they're decoded by Encase as you see in the above screenshot. Inside of Encase, we can also use the decode feature to decode that information. Conversely, we can also take a value from the registry or any other source and use a program called Decode, which is available for you free of charge, and we'll cover that very shortly. Other date and time formats that you'll find inside the registry, meaning inside of the values themselves, is typically DOS date and time, a DOS date and time in GMT, UNIX 4-byte values, 32-bit values, also in Big Endian. You also find UNIX numeric values, which are 10-byte numeric values. You'll find HFS dates, HFS plus, and then finally you'll see the Windows file time value. Now there are more that are on the screen in the screenshot to the right, and that screenshot is taken from a program called Decode. And these are other capabilities that the program Decode will avail to you. And some of these that you see on the screen may appear for you inside the registry. So having a utility that's capable of translating these date and time values is going to be very important to you. So an example here, I've taken a screenshot of a 32-bit UNIX date and time value that's 4 bytes in length of the installation date for an operating system. And I'm currently looking inside of a registry hive in the Windows NT current version SubKey at a value called install date, and then the value data itself is the hexadecimal values of E6995654, which I've then copied into the program Decode, and I set an offset of -0500 or 5 hours from GMT to display the correct offset. The next example is a UNIX numeric value, and these are pretty common inside of the registry for various programs. Google is notorious for their applications and having UNIX numeric values, as well as some of the peer-to-peer applications that you'll find out there on Windows machines, which write registry values into the ntuser.dat or software hives or related hives that may be applicable. So in this example here, I'm going to type in this value of 1065.644.901, and you can see here that I've placed the value to decode in this field. Next, I'm going to place an offset of -0500, which means that I'm going to decode this from Eastern Standard Time. I also need to come in and select the type of value or the decode format. So when I come down to UNIX numeric value and then I hit the decode option, it shows me the exact date and time for that particular value, which is Wednesday, October 8th, 2003 at 15:28 hours. If you wanted to record this information, you could then copy it to your clipboard and then paste that value into your notes or into your report, however you deem necessary. As I previously alluded, the only object that consistently records a date and time value within the registry hives is the key or the subkey, meaning the folder. Value names, types, and data, they do not record the last modification date and times in almost every instance. There are some exceptions to this, but fundamentally when you look at the structure of the registry, only the keys or subkeys will store a last modification date and time. So if a child object of the subkey is changed, any of the values, then the last modified date and time of the subkey itself, the parent, will reflect the date and time of the change. In the screen before you, we're looking at the ntuser.dat file and specifically the typed URLs subkey. So here it's displayed for you in the left pane, the typed URLs subkey, and then you can see the content of the typed URLs, which is actually the URLs that were typed by the user into the Internet Explorer browser. They are stored inside of the ntuser.dat registry hive. And so you can see in the examples here, these are the various URLs that were typed into the browser. When we look at the key properties, we see that the last time that this was modified was on 12/7/2014 at 23:36 UTC. And of course that is not reflecting the current offset from GMT. Now what's unique about typed URLs, not to get off on a tangent, but in Windows 10 there is a new subkey called typed URLs time, and this is stored separately. When we go and take a look at the typed URLs time, you'll see here that for URL1, which URL1 by the way is google.com, we see that the URL time for that has a value, data, of 64-bit value, meaning 8 bytes, and this should look relatively familiar to you since we just covered this in the lesson. You'll see that the value ends left to right in hex 01. If I right click inside here, I can go to an option called hex interpreter window, which you cannot see on the screen, but it's in my right click menu. When I go to the hex interpreter inside of the registry viewer, I can then see that the stored value there is 12/7 at 23:36:12, and then the local time is 18:36, which is an offset of 5 hours from GMT or UTC. So this gives me the ability inside of Access Data's registry viewer to interpret the date and time value that you see inside of the value data itself. Now back to the point of the key or subkey holding a last modified time. Here you can see that the last time this particular subkey was updated with any of the values was on 12/7/2014 at 23:36. So it remains consistent that fundamentally the subkey and keys only maintain the last time that the subkey was updated. Inside of the live registry there is a hardware subtree that's not viewable inside the static registry, and once again this subkey is only viewable when Windows is actively running, and you can view this inside of Registry Editor or with other applicable tools. Looking at regedit in a little bit more detail, we look at the SAM file or the SAM hive itself, Security Accounts Manager, and you can see that the permissions do not allow us to look any further into the SAM, whereas before in previous slides we look at the contents of the user subkeys and the V and the F files that are contained therein, and allows us to look at the full structure of the SAM hive. So again, it's very limited in this view. When we look in the view of Encase to screenshot, again we see the full structure of the SAM hive starting up here at the SAM subkey, going down